All right, so this is going to be a video about simplifying complex numbers, and to kind of teach this concept, I'm just going to be working through a bunch of examples essentially, and hopefully that helps with understanding how to do this. All right, so this first one, it says the square root of negative 16, so I'm just going to write that down here. The square root of negative 16 plus the square root of negative 4. All right, first thing that you need to see when you're working with this is that both of these are going to be involving imaginary numbers. So the square root of negative 16, the square root of negative 4, both of those terms are going to be imaginary numbers. So first thing I'm going to do is factor out the square root of negative 1 for each of these. So that's the first thing I'm going to do. So you end up with something like that. Then from here, I'm going to simplify anything that I can. Part right here is going to become 4. This part right here is going to become I, so this just becomes 4i. Okay, then you're going to be adding. This part right here becomes 2. This part right here, again, is I. So you end up with 2i there. And then you just do 4i plus 2i is 6i, and then you have your answer. All right, the next one. I'm going to rewrite this one really quick. All right, so for this one, we are adding a complex number with another complex number. And the easiest way to do these is to combine the part where it involves the real number. So right here, it's going to be 5 plus negative 6. And then we're going to add that to the two imaginary numbers, which is going to be 4i plus 2i. Okay. From here, I'm going to combine this section right here to get negative 1. Then I'm going to combine this right here to get 6i. So you end up with negative 1 plus 6i for the final answer. Let's move on to the next one. All right, this time we're multiplying two complex numbers. So we have 10 minus 3i times 10 plus 3i with parentheses around each of those. Now to solve this one, I highly advise using the area model, which basically what you're doing is creating a rectangle where it has the length of this and the width of this. So that's what I'm essentially going to do here. So I'm going to write 10 minus 3i, okay? And this is going to be the width of the rectangle. Okay, then the other one is 10 plus 3i, so that's going to be the height of this rectangle. So we have the width and the length, or the height, or the base, it doesn't really matter, but you can see that geometrically we're using the area of a rectangle in this case to figure out what these two things multiplied together are. Okay, it's called the area model. All right, from here I'm going to fill in the area for each part of this. So this one's 10 by 10, so this one's going to be 100. Okay, this one's going to be negative 3i times 10. So it's negative 30i. So essentially all I did was multiply this part and this part to get this part right here. Okay, I multiplied this 10 and this 10 right here to get the 100. Okay, so I'm just doing basically where they cross for each of these. So this one, it's 10 times 3i, so that's 30i. And the last one, it's going to be negative 3i times positive 3i, which is going to be negative 9i squared. All right, so the next thing we're going to do is we're going to add up everything that's inside. So we're going to add up all these areas, this area, this area, this area, and this area. So we're going to add those all up to get the total area. You end up with something like this. Okay, from here we're going to simplify. So negative 30i and 30i would cancel, and you end up with 100 minus 9i squared. Well, I squared is equal to negative 1. So if you simplified this, it'd be 100 plus 9, which is 109. It is also important to stress that you can check all of these on your calculator as well. If you have a TI-84 or even an 83, you should be able to use the I button to calculate this to make sure that you actually did it right. All right, moving on to the next one. All right, so the next one we have 5 plus 4i quantity squared. So again, we're going to use the area model for this. It just makes things a little bit easier. Sometimes this is called the grid method as well, or the tabular method. It's all the same kind of thing. It's just a great way of organizing your math work and making sure that you're concise and precise with all the numbers. you end up with something like this. This would be a square because the length and the width are the same. Not that that matters, but so we're going to do the 5 times 5 here to get the 25. Then we're going to do the 4i times the 5 here to get 20i. Okay, we're going to do the same thing here, 5 times this 4i right here to be 20i as well. And then last but not least, we're going to do 4i times 4i, which is going to be 16i squared. Okay, the next step is to add all these up. So we're going to have 25 plus 20i plus 20i is 40i plus 16i squared. Okay, from here I'm going to simplify. This I squared is -1. So this thing right here is going to be times -1. So it's going to be 16 times -1. So we're going to have 25 minus 16 is 9. And then plus 40i. And that should be the final answer right there. And again, you can check these on your calculator, so make sure you do practice doing that because it could help you. All right, looks like we got one more, and it involves some radicals in that complex number. So we're going to do 2 plus I root 3 times 2 minus I root 3. Okay, again, I'm going to use that area model to figure this one out. Okay, this one's going to be 4. This one's going to be 2i root 3. This one's going to be -2i root 3. And this last one is going to be -I squared times 3. Because the root 3 times root 3 is 3. And then the -I times +I is -I squared. Okay, we're going to simplify this. So we're going to have 4. Well, this and this are going to cancel, so I'm not even going to bother writing that down. It's going to be 4 plus -I squared times 3, okay, which is going to be 4 minus -1. So I just wrote that as -1 there. The minus is right there, times 3. And you end up with 4 plus 3 is 7 for the final answer. So those are some example problems involving simplifying complex numbers with varying operations. We did some adding, we did some subtracting, we did some multiplying of two complex numbers. If you have any questions about anything in this video, let me know.